Welcome everyone. This is the session 3 of how to get your AWS Cloud Practitioner Certification in 2 weeks. Um, Earlier, my name is Anant. Um, I have over 3 years of experience with AWS. I'm a Google certified professional cloud architect. I recently also completed the AWS Cloud Practitioner Certification in October 2021. I also have 3+ years of GCP cloud experience. That gives me balance of multi-cloud experience. I'm happy to help you with the certification today. Um, we Just to remind ourselves, there are 4 basic domains that we need to cover to get our certification. We'll go through most of the concepts today, and then we'll get to some questions in the next session. Last session we covered the cloud concepts. We covered number of concepts, and then we went through some example questions. Today we'll go through security and compliance, which is our next domain. This is another important domain. It counts to about 25% of the total number of questions that you get. Um, as usual, please don't forget to subscribe. We have 7 more sessions to get completed with our AWS Certified Cloud Practitioner. Like this, share it with your friends, please. For today, there are a lot of AWS services. Like now, we want to focus just on the security and compliance services. Within security and compliance, you can probably see a few major like categories. One is governance, where how do we govern all the like organizational information using AWS organizations? How do we have a resource access manager, a directory service, security hub, AWS artifacts that helps us with understanding all the needs, the governance needs, the compliance needs, um, the cloud directory. The next category is audits and scanning. So an important part of security is, are you able to scan the information and get everything that you need? Are you able to audit your information and be able to provide reports when needed? So those the services that fall under that category are Amazon Inspector, AWS Config, AWS Cloud Trail, AWS Trusted Advisor, AWS Detective, and Amazon Macy. The next set of security and compliance services that AWS provides are endpoints, application endpoints. So when AWS interacts with the external world, those are called endpoints. So how does AWS provide services to manage entry points and exit points from into AWS? So one is AWS Certificate Manager. Next is AWS Shield, AWS WAF, AWS GuardDuty, AWS Firewall Manager, IoT Device Defender, and Cloud NDR. Little bit more important are the next 2 pieces. From a exam perspective, you get a lot of questions with respect to access and keys. So access users, IAM, which is something we'll delve upon pretty quickly. IAM Analyzer, AWS Single Sign-On, Amazon Cognito. So we'll focus a lot more on IAM in this piece, but the others we'll touch upon. Um, Key related services are AWS HSM, AWS Key Management Service KMS, AWS Secrets Manager. This is another piece I think a lot of questions come from. So we'll just dive into these services one by one, and we'll also go into the concepts so that we understand what we're trying to achieve here. The first concept we need to understand when it comes to storing data in any server, whether it's going to be on-prem or on the cloud, is going to be encryption. And there are two types of encryption that we do. One is any data that is at rest, that is, it's stored in your folders, it's stored in your devices, it's stored in the server, it's stored in a database. All those things are data being stored at rest. Like in AWS, you could store it in an S3 bucket, you could store it in an RDB PMS database. So any of those would be data at rest. So when we store the data at rest, we encrypt the data and store it. And data at transit is whenever the data is transmitted either using an API or while calling transmitting data from your system over to S3, transferring data or downloading data from S3 onto your server or your local machine. All those things are when data is in transit, and we want to make sure that any data that is in transit is not interfered by external party or someone else, and they should be able to acquire the data and understand what it is. So if you look at the left bottom, we talk about a cryptographic key. This is the key point we use for encrypting data. So the key is just like a key that opens a door. It is only held on to by the customer, so not anybody else can use their key to open the door. But it's not an actual physical key. A cryptographic key. I'm sorry, I'm stammering here. A cryptographic key is a random string of digits. It's a very long string of digits used for locking, that is encrypting the data, and for unlocking, that is decrypting the data. So unless somebody has that long string of digits in the exact same order and exact same set of digits, they will not be able to either lock the data for encrypting or unlock the data for decrypting. So if you look at the top right there, encryption, what it does is it prevents unauthorized access. So if you look at DynamoDB, that's an example where you store data in a database. We use encryption at rest. Here we also talk about key management service. So the keys that you need to actually unlock the data can be stored in a key management service that AWS provides, which is AWS KMS. And you don't have to use that. There are other third-party tools available as well. Certain companies don't use AWS KMS and they use another third-party tool. But that is one example. AWS provides KMS, a place where you can manage the keys. So that is being provided by AWS as well. So that key is what will allow you to access the data. Without that key, if you lose the key, you won't be actually able to access your data. So that at the top right there, it talks about encryption for data at rest. Let's say we have a Redshift instance. In the top bottom, we'll talk about how data in transit between a Redshift instance and to an SQL client where we run a query so that we get data from Redshift. On your local system, you have a SQL client, say Toad, or like we can use that and like connect to a Redshift instance, and then we run a query. When we connect to it, we use something called secure sockets layer or SSL connections. So the SSL connections encrypts the data before it sends over the internet. And we can use service certificates to validate or authorize a client. That is, whenever the data is passed between Redshift, which is on AWS, and the client, say we are running it on a local machine, the data when it's being passed that data is protected because it's encrypted. And like this is not only in Redshift. AWS provides this encryption in transit in SQS, S3 buckets, RDS, and many more. More to the next one. With respect to encryption, I think there are two major concepts that you need to understand. One is that it's a choice for customers. The customers could choose a client-side encryption, that is any application that sends data to AWS or retrieves data from AWS, encrypts it before they send it, and after they get it, they'll not be able to identify what it is immediately, so they'll have to decrypt it before they read it. This is client-side encryption. That way, any applications to the left side, you see that any applications in your data center or any applications that are in Amazon EC2 that go and access the RDS or Redshift, they'll have to have a key management system so that they know what key to use, and then encrypt the data before they send it over. And then when the data comes back, they need to be able to decrypt the data. So they need the key. Say if this is a server-side encryption, then the AWS encrypts the data and manages the keys for you. So in this instance on the right, you see that the data is still sent securely through HTTPS, but the data is not like encrypted before sending over. There is a server-side encryption that happens, and the data that is stored in S3, if somebody gets the raw data, which is clearly impossible in today's AWS security controls, but say somebody gets access to the EBS volume or the S3 data or the RDS instance, they'll be able to get the data, but they'll not have a key to decrypt it. And because AWS manages the key, unless they get the key as well, they'll not be able to actually understand what the data says. So this is encryption. So let's go on to the key management service that we spoke about. Like this diagram at to the right, it shows about how a plain text data that we want to store gets in. Like we use a data key and we use an encryption algorithm so that we can choose. There are a few encryption algorithms to choose from that gives us an encrypted data, but that's just not stored there. To actually store it, we take the data key and then use a master key, which is again stored in AWS KMS, use the same encryption algorithm, and we get an encrypted data key. So even the data key is encrypted, and that encrypted data key and the encrypted data goes into storage. So so we need the master key to first identify what the data key is before we can actually decrypt the data. Like even though the key is stored, so we would not be able to decrypt the data unless we know what the master key is, which is stored in AWS KMS, and all those keys are managed by AWS. So coming to the left, so now that we understand how encryption happens and how it gets stored, AWS KMS can manage all this for you. And with AWS KMS, you can actually choose specific levels of control that you want for the keys. You can actually specify which users and roles are able to manage keys. Also, you can say certain keys can be disabled so that nobody can use them, or you can manage them multiple other ways. The keys need not be stored in your local system because it's AWS manages the service. All your keys can still stay within AWS KMS. And note that AWS KMS is separate from S3 or your RDS. So these keys don't get stored along with your data in S3 or RDS. Those are stored separately in AWS KMS. So that way we have protection over the keys. Now that we understand how we encrypt and decrypt the data, how we have keys and how we manage, how AWS is able to help us manage the keys, we will go on and understand how we will create a user and how we will provide them permissions to actually read data in read or write data into AWS. So the first major thing in AWS is a user. So when you create an AWS account, you go log in and you go register, and you figure out that you want to set up an account in AWS. The first thing that AWS allows you to do is create a root account user. If you used Linux earlier, you will understand root user is the owner of the AWS account and has permission to do anything they want inside of that account. So this is kind of a master account. This is typically owned by one person at the company, um, and those users are highly capable. So even if one person owns it, they rarely use this. Sorry about that. After you create the root user account, then each user that needs access to log into AWS, either they want to launch a new server, an EC2 instance, they want to create a new bucket where they can store files, all those any other thing that they want to do with AWS. Typically, they'll create another user ID. When you create a user ID, it comes out with 0 permissions. So the user ID that you create is just it just gives the ability for someone to log in or use an API through the access keys. But as soon as the user is created, it cannot create a S3 bucket, it cannot launch a EC2 instance. Each user has to be specifically given permission to do anything in the account. So by default, all the actions are denied. Any action that the user has to perform has to be explicitly allowed. And the major principle that gets asked in a lot of questions is that least privilege principle. So the access you give to people should be just what they need and nothing more than what they need. You should never give them an additional access than what they would actually need. And this is very important as we get into all clouds, the least privilege principle. I've seen that in on-prems, a lot of people get root user access. If there are 10 administrators, like most of them have root privileges, and they're able to like create directories, set up new services and stuff like that. They're able to install stuff. But with respect to cloud itself, not only AWS, other clouds as well, they reiterate the importance of least privilege principle. So by default, the users have no access unless you explicitly grant them any permission. They'll not be able to do anything. That is the least privilege principle. Next, we'll move on to IAM. Again, as I said earlier, this is one area where there are a lot of questions that come up, or I'm pretty sure at least 1 or 2 questions will come up in your exam. So just buckle up for the ride. IAM essentially gives identity and access management. So identity is any person, like user who wants to log in, or a group, say developers group or a tester group or a admin group, or a billing group, finance group. So those users can be grouped together as a group, and a role is an identity too. So those are identities. A role is not a specific person per se, but something that a user assumes or AWS resource assumes. Say, for example, an EC2 instance can assume a role, and then based on that role, um, they'll be able to do certain things. So identity is the first part, and within identity we have users, groups, and roles. And the access management is the next part, where we talk about permissions and policy. So what happens when somebody has identity? That means they're able to log in, and we know this is the right person. But to actually, for them to be able to do something, they need to have certain permissions, either based on they're logging as a user and they have a permission based on that, or they are associated with a group, and that group has some permission to do certain things, or they're assuming a role, um, or that particular resource is assuming a role, and that has the permission to do something. So the second part of IAM is access management, and that comes in permissions. So permissions describe what particular operations any identity, that is user, group, or role, may or may not perform. And these permissions are actually in a JSON file, in something called a policy. In a policy, you can actually write a policy to allow certain thing or deny certain things. So you can write it either ways. And then that permission is provided to a principal. A principal can be a role, user, or a group. And since everything is denied by default, typically we write the policy to allow certain things. But in some cases, say we allow access to all S3 buckets, but we deny access to just the finance bucket. So we could do that for a developers group, where we allow them access to all the S3 buckets, which is not the right thing to do, but I'm giving an example so that we can understand when we will use a allow rule versus when we provide a deny rule. So within the policy, we write a JSON document. We assign the principal, that is who this identity is. That is it a role, a user, or a group? And then for them, do we allow access to a resource, or do we deny access to a resource? So now that we understand users, groups, and roles, I'm pretty sure a lot of people are confused about what a user is and what a role is. So a little bit of context here. If somebody is able to log in to the AWS console, if they have a password, then that is a user. If they have an access key, so they could go in and log in with the API, or get in for testing using the CLI, then that is a user, not a role. Users can belong to groups, not roles. So users can belong to a developer group, or a like tester group, or admin group. Roles cannot. If you can associate the identity with the AWS resource, for example, this EC2 instance can do this, or like this Lambda function can do this, then that is actually a role, not a user. Does this mean like any person would be a user and any AWS resource can be a role? In most cases, yes. But certain cases, for instance, in the previous company I was working in, we never created IAM users for every person in the organization. Rather, we used their corporate credentials that they currently have, the LDAP that they log into, the Okta that they log into, and that mapped them to an IAM role, say if they're a developer role, they get into a developer role, and then they are able to authenticate themselves as a like after they log in through their corporate identity, say through Okta or LDAP, they get in to AWS using the role that they are assigned to in their corporate identity, and based on that, IAM authenticates them and provides them access for that particular role. And based on that role, we look at the policy and see what permissions they have, and based on that, they'll be able to do or not do certain things. So that was a tough topic, but a lot of questions would be covered by that. A little bit of more information about IAM. As we said earlier, IAM has two parts. One is identity, the other is access management or permissions. Identity, you can have users, groups, roles. There's also something called credentials, not important for this exam, so not covering it. And access management is actually permissions that we provide, and those permissions are provided as a part of a JSON file called policies, and the policies actually has statements inside it. That's pretty much what you want to know for this exam. We don't need to go much more in depth, at least for passing this exam. One particular thing that might get asked, I did see one of the questions about this, but I was not asked in my exam, is about policies. So there are two types of policies that we can provide. One is identity-based policy, which I spoke to a little bit earlier. Say we can say this user or this role or this group is able to access this S3 bucket, or is able to write to this S3 bucket, is able to call this API, right? So that is an identity-based policy. We could also have a resource-based policy. That is, we could say like this particular EC2 instance can be viewed only by this group, or this particular S3 bucket can be written to only by group A and can be read to only by group A, B, and C. So we can actually like have a policy that is based on the resource itself rather than the identity. Again, I think this is very rare that you get this question, but good to understand it. Let's move on to the next topic, which is the shared responsibility model. Another very interesting and important topic. I'm pretty sure like most of you would get one question about shared responsibility model. So I'll take up a question after we talk about shared responsibility model, just to give an example. But if you understand this, you'll be able to pretty much answer any kind of question that AWS asks, throws at you. So the terms that AWS uses is that AWS, if you see the bottom there, is the responsibility is AWS's responsibility is the security of the cloud. That is anything that to do with the regions that they have, the hardware that they have. So any like physical infrastructure that they have. So anybody coming into or getting out of this the server infrastructure, or anything that happens with respect to the server like tools. So those kind of things they'll take care. Any networking that takes care that is with respect to the infrastructure itself. Any storage and database that they do based on their infrastructure, and some software that they provide as a service, and any database that they provide as a service, any compute that they provide as a service. So they take care of those security aspects. So for example, they make sure somebody cannot get into an AWS building and change something. If anything that is networking between an AWS availability zone to an other regions somewhere else in AWS, they take care of the networking. But any customer data, like any like this is as far as AWS responsibility goes. So any responsibility they term is security of the cloud, and according to their terminology, responsibility of security in the cloud is with the customer. That is, this is easily understandable. Any customer data that they store. Say for example, we spoke about an example of chat server. So any messages that come through on this chat server, any profile information that we have on our like people who use the chat application, any photos that they send or any photos that they store as their profile information, their phone numbers, all those are customer data, and those would have to be secured. The security of that is the responsibility of the customer. That is, we who run this app on the AWS platform. Any application that we install on it, any like IAM roles that we define, that's our headache. We have to, the customer has to ensure that we define the right roles, the right user accesses. We shouldn't give more than what is exactly needed. When we do a EC2 instance, then any operating system patches that we do, that is responsible by the customer, even though hardware patches are a responsibility of AWS when it comes to a EC2 instance. Any networking and firewall configuration, the VPCs that we set up, virtual private cloud, that is a network which is virtually setting up a barrier network. Any firewall configuration that we do, that is allowing and not allowing any kind of IP addresses to able to communicate with us. All those things are responsibility of the customer. Any client-side data encryption that we do, any server-side encryption that we do, networking traffic protection, so that any traffic that comes in and goes out of our applications, those are all our responsibility. Say somebody wants to do a DDoS attack on us and they keep hitting our application. So we have a web application and they hit our application multiple times. So those kind of networking traffic protection is the customer's responsibility. So this is what AWS calls as a shared responsibility model. So if you look at the right, this is it's similar to how a homeowner and a home builder share responsibilities. The builder, which is similar to AWS, constructs your house. So anything with respect to constructing your house, make sure it's solidly built, make sure the foundation is strong. That is the builder's responsibility. But the homeowner, make sure he locks the door, like make sure there's no fire hazard, make sure there isn't a window that's open. So all those things are responsibility of the customer. So that's the kind of analogy we can use. So probably a little bit of complexity here is with respect to networking, because the physical networking between between places is taken care of by the actual AWS, but any networking kind of VPN that we put in is the responsibility of the customer. Similarly, when you build your own EC2 instance and set up a database on it, the whole database software, any patches of database that we need to put in, everything is the customer's responsibility. But when we use a DynamoDB or any serverless database that we use, such as RDS, those are the responsibility. The patches in the database and everything is the responsibility of AWS. So that's where the line is not very clear. So depending on whether you do a platform as a service or infrastructure as a service, the responsibility between the customer and AWS, the line is drawn differently. So that is something we might get a tricky question on. So I'll cover that in the next couple of slides. So the customer responsibility is security in the cloud, as I said. Um, so um, so this customer responsibility will be determined by the AWS cloud services that a customer selects. So if they build only EC2 instances, then any kind of operating system we put in there, any operating system patches that we need to, everything is our responsibility. But we choose only Lambda services, and we build just um, like the APIs over the Lambda functions, then the responsibility of the customer is very much different. So we're not responsible of any of the operating system patches. They're not really responsible for any platforms, but we are responsible for the application we write, the IAM we provide, any network configuration that we do. So that is a very varied line of difference between the determined by the AWS cloud services that a customer selects. Let's look at the AWS responsibility. So AWS responsibility is to protect the infrastructure that runs all the services offered um, in the AWS cloud. The infrastructure in this instance means the hardware, especially some of the software that AWS provides, that we can directly run, not the software that we install on it. Any networking of the physical infrastructure that they provide, the facilities that they run the cloud services in, all those things are AWS's responsibility. Okay, so let's look at a question. Which tasks are the responsibility of customers? And they're asking us to select two of them. Maintaining network infrastructure. So as we spoke about, any physical infrastructure network that is provided is AWS's. So I'm going to say no to that. Let's move on to two. Number two is patching software on Amazon EC2 instances. After the EC2 instances, we choose a EC2 instance and we set it up. Those are virtual servers that we own. So any software that we need to patch on that, even OS updates that we need to do, everything is our responsibility. So that is the customer responsibility. So for two, I'm going to say that's probably one of the answers. Moving on to three, implementing physical security controls at data centers. So this is definitely not the customer's responsibility. Customer wouldn't even have access to get into the data centers. So that's definitely AWS's responsibility. So I can reject one and three. Let's move on to four. So it's got to be two and then four or five. So let's look at four. Setting permissions for AWS Amazon S3 objects. So we can set whatever permission we want. We can allow that to be read by the entire world, from anybody, from any IP address, or we could restrict it completely to say that only this user can upload it, this user can download it, or we could give it to a role or user group. So any permission that we set can be done by us. So I believe that should be our responsibility. But before I choose two and four, let me look at five and make sure I'm not missing anything here. Number five is maintaining servers that run Amazon EC2 instances. So Amazon EC2 instance is a virtual server that we get. Even though we manage the EC2 instance, they actually run on a server, and that could have multiple EC2 instances running on it. We have no control over it. So it's not going to be in any way possible for the customer to maintain those servers. So I'm going to stick with my choice of 2 and 4 and click and see if I'm right. Okay. I believe that was right. It didn't show me the answer, but I'm going to say I was right. This is the last slide I want to have about IAM roles. Shared responsibility. and I want to show how it differs, the responsibility between AWS and like the customer differs depending on whether it's on-prem, IaaS, PaaS, or SaaS. So SaaS is software as a service. That's when we use Google Docs, or when we use any web application that's completely run in a different cloud environment, and we just like set up credentials and log in and use it. So those applications are completely the provider's responsibility. But when we move to the left, from SaaS to PaaS, which is platform as a service, when it comes to platform as a service, like we can implement any kind of applications on that. We can put in any customer data on that. So in that case, any applications that we install, any customer data that we have, would be our responsibility. But any runtime and middleware and operating system would be the provider's responsibility. In this case, AWS. With that said, let me go up and read the top. For any serverless functions that we build on AWS Lambda, that is actually a platform as a service. So AWS manages the underlying infrastructure and foundation services. They take care of the operating system, the application platform, but any application that we put on that, any code that we write on that, say it's a Python code that we write in AWS Lambda API, that code, what it does, the security of that code, and the IAM roles that we provide so that those APIs can be accessed, all those are our responsibility. So it's customer's responsibility for those. Going back to the diagram on the bottom. So if you look at IaaS, which is infrastructure as a service, that's like an easy to instance. So when it comes to easy to instance, you can see that the customer responsibility has increased a little bit more. So not only the applications and customer data, also the runtime, any middleware that we have, any operating system that we need to put in, any operating system patches we need to put in, any software that you install on top of the operating system, that includes middleware and runtime. Everything is the customer's responsibility. Still, the platform provider, that is AWS in this case, takes care of virtualization. That is actually creating ACT instance out of a huge server. That's called virtualization. I mean, I'm keeping it simple here, but in case you already know. Otherwise, this is a simple way to understand what virtualization is. Any physical networking that they do, any storage, physically, servers physically, all those things are taken care by the provider. When it comes to on-prem, everything is the customer's responsibility because everything is on premises, and like whether it's going to be preventing somebody to actually physically go into the data center, or whether it's going to be putting in operating system patches, or making sure the application doesn't have any vulnerabilities, everything is our responsibility. Okay, that kind of takes care of a lot of the important questions that will come in for this. But there are a lot of other topics where they could pick and choose and ask one question, or they may not even ask one question from compliance, one question from security. So I'm going to go through all of these. So let's look at these with the lens that you would get one of these questions from the next few slides. But the previous slides, you'll definitely get questions from IAM roles, shared responsibility. I'm pretty sure about that. These next slides, say for every 3 to 5 slides, you'll probably get one question from that. So it's important, but it's not going to be essential to understand all the basics of this. So we'll rush through this for the next 15 minutes. AWS Compliance is a portal. So it's a portal where we have a lot of information. So like when when AWS wants to make sure its system is compliant with HIPAA. Okay, so HIPAA or payment card industry, PCI DSS, these are two different compliance regulations that the US government regulates, and a lot of other um, countries as well follow this. Or follow, they have a similar kind of legislation that they require companies to do. For example, HIPAA is a Health Insurance Portability and Accountability Act. So anybody who stores health records, whether it's a hospital, whether it's a provider, whether it's a pharmacy, so anybody who has um, information about patient records, they have some responsibility to store securely, store the data securely, and provide some kind of compliance with certain laws. Similarly, with payment card industry, anybody who wants to sell online, they store a credit card on the database, so they need to handle that information very securely. So there are some rules according for that. Those are payment card industry rules, and there are many other legislations. So if you want to understand anything about these legislations, go to the AWS compliance page, and this is a open page. It's, you don't have to have a AWS account to be able to log in here, and then that would give you information about any audits that they've created, that they've done with other parties, that shows that AWS itself is HIPAA compliant, or if it's PCI compliant, so that it would give all those information. And if you're working in a different industry and you need your industry related compliance information, you go to this website. It tells you all the kind of legislation that you need to comply with, and how AWS already helps comply with this. So very important to understand here. Probably not for the exam, but more so while using this. The compliance is again a shared responsibility. Any data that we store, we need to make sure it's PCI DSS compliant. Like say if you're showing customers credit card information, you need to make sure that's compliant with the legislation. It's over and above what AWS provides. So AWS provides the ability for you to securely store the data and securely transfer the information when you transmit the information. But whether you do it, whether you set it up that way or not, is the responsibility of the customer. So, but there can be a lot of information provided in the AWS compliance site. So AWS compliance site is essentially a site where there's a lot of information about how to comply with all the legislation, and if AWS already has been certified in certain things, they have all those reports from third parties that say that AWS has been tested and they're able to comply with this. Next is AWS Artifact. Again, AWS Artifact is a self-service portal, and this is also an open portal. You don't need to log into your AWS account to be able to access this, and so you can go in there and figure out all the compliance reports. So there are two sections to it: AWS Artifact reports and AWS Artifact agreements. Reports are where you choose your compliance program, say it's PCI DSS, and then you download a PDF. It has links to all the compliance reports from third party that AWS has already provided, and also provides with kind of some information about how you can comply with those as well, in addition to what AWS already tested and provided reports for. So essentially, if you go download the PDF, it will give you a link to multiple reports that third parties have tested and proven that AWS is compliant. The second section is the AWS Artifact Agreements. So here is where like any agreements you want to like have with AWS, you can go in there, review the agreement, accept it, and sometimes reject it. You can essentially manage all the agreements in this area. So that is pretty much what you need to understand with respect to AWS Artifact for the exam perspective. So it's an open website where you can go in and like for the AWS Artifact agreements, I believe you have to log in and you might have to set up either an organization, or you might have to like as a, if you have an individual account, you use it as an individual. If you have a organization set up, so you can accept it either for the organization or for a part of your organization. And if you accept it for the organization, so everybody is able to view it within your organization. Everybody is able to view it, and everybody would have like agreed to those terms with AWS. So probably I'm wrong with respect to login, or probably the reports you could still get it without logging in, but to get the Artifact agreements, you need to be able to have a login with AWS so that you can actually like print out your agreements, look at your agreements, accept it, and then print it out. The next thing we look at is Amazon Inspector. Amazon Inspector is essentially an automated security assessment service. So what does it mean by automated? So this can be run manually once, yes, but you can also run it, you can set it up to run every week, every month. And what it does is it does a security assessment for you. So it kind of runs your assessment and provides a report. Again, this is a PDF report. But what that says is, okay, these are your potential security issues, and these are your recommended fixes. What does it help you do? It helps you improve your security and compliance of any AWS deployed applications that you're running. Like if you have a EC2 instance, like are you opening up too many IP addresses than is needed? So if you have two EC2 instances, one is open to the public and the other one is open only to the first EC2 instance, so it'll caution you based on what kind of network setup you have, what kind of firewall setup you have. If you have EC2 instances without the latest fixed patches updated, those are security vulnerabilities that will show up on your report. So essentially there are three pieces. If you look at the bottom of this, a network configuration reachability piece, which is actually whether your EC2 instance is configured with the right network firewalls, access control lists, so those kind of things. And an Amazon agent, which can actually be installed on EC2 instance, which can monitor the EC2 instance and make sure there's not any vulnerability that is happening or any breach of security that's happening. And also a security assessment service that actually brings everything together and provides a full list of all the security issues and what kind of fixes you can do to achieve a good security standard. So Amazon Inspector, if you get a question about it, so typically there'll be like a question with like 4 options. One would say Amazon Inspector, one would say some other thing, and they would ask what would you do to when you need to like automate your security assessments. So the answer you would have to choose would be Amazon Inspector, but they might ask something pretty close to it, and you might get confused. So that's one way they kind of get you. So one question I saw where they were pretty much asking about security risks, and they had multiple options, and the two confusing options that they had were Amazon Artifact and Amazon Inspector. So that question was, which provides a PDF with all the security vulnerabilities. So in both these cases, we do get a PDF report. But what is the difference? In Amazon Inspector, the report says whether your application is vulnerable to risk, and it also provides some actions that you can take to do that. Um, so, but with respect to Amazon Artifact, though, the one to the left, we talk about like whether AWS meets the security and compliance frameworks that you're looking for. So you can go in and choose your compliance framework, and then it will give you a PDF of like what are the tests that have been done, what are the security controls that AWS has, and then it will come up with a report. Like for instance, PCI, SOC, HIPAA, those are kind of the compliance frameworks that are typically talked about, but there are like so many more in that. Okay, that is one tricky question. We'll move on to the next one. Amazon GuardDuty. Um, Essentially, what you need to know about this is it's a threat detection service and it uses machine learning. So, what is a threat detection service? Amazon GuardDuty monitors the logs. As essentially, there are three types of logs: CloudTrail logs, VPC flow logs, and DNS logs. What it does is it continuously monitors it for any suspicious activity or unauthorized behavior, and it provides an alert out. You can use the alert to actually do a CloudWatch event or a third-party service, or you can just email it to yourself and like make sure you know whenever a threat is detected. What is a threat? For instance, when we look at the DNS logs, which is the domain name service, if we look at multiple like instances where our domain name service has been invoked, then that would be flagged by Amazon GuardDuty because it monitors for any suspicious activity, and if the number of requests for DNS is increasing a lot for our domain name service, that means somebody's hitting it multiple times. That could be a malicious activity. So that is immediately alerted to us. And if it's just an email, we'll get an email, or we could actually set a CloudWatch event, which actually either shuts down a service or like does any other thing based on what we wanted to do. So let's go on to look at the bottom picture here. When we go into a console or through a CLI, we should be able to enable Amazon GuardDuty. After we enable the GuardDuty continuously analyzes the network, checks for any account activity and network activity, and as we said, it uses machine learning, so intelligently detects the threats. So anything that it is out of the ordinary, the GuardDuty learns to detect it, and then it can send out an email. We can go into GuardDuty, check, review it, and take actions based on like what actual threat we have received. So will it affect your performance? That's one question like we always get. Because GuardDuty is run independently from other AWS services, it shouldn't affect your EC2 instance or your Lambda service. So this is a separate compute workload, so it should not affect your existing infrastructure that you have set up for this. This is the next one is a Web Application Firewall. So a GuardDuty is not actively doing something. It monitors the logs and then sends out request. But if you want to like after you look at the guardrail, you figure out that there's been a threat coming in from one IP address from Russia that's hitting you multiple times for some malicious reason, then you could set up a access control list or a web access control list. What that does is If you look at the bottom, we have a AWS Firewall Manager, which actually manages multiple web application framework deployments. And for our application, there is one web application framework that the firewall manager points to, and that protects the web application um, from anybody coming through the API gateway or through the application load balancer uh, to get in and get it blocked. So we can actually build our own rules. We can code it in JSON, and then we will be able to protect certain attacks, like known attacks like SQL injection attack, XSS attack. Those are well-known attacks, and we can say these IP addresses are blocked. These kind of patterns of IP addresses are blocked. Anything starting with these IP addresses are blocked. So we can set up things like that, and we can monitor what's happening with CloudWatch and Amazon Kinesis Firehose, and then we can change the rules based on what we see. Again, let me go to the top, the images there. So we set up a web application firewall by editing something called the access control list. The access control list is similar to a network access control list, but it's a web access control list, and it protects your web application. It is just at the network level, which is at the top level before anything enters into your application from external to AWS. While network access control list could be within your VPC. So this is at a much more external endpoint, and it can block the malicious IP addresses or any malicious requests from a much wider circle. So at the top there, we get a request from a customer. They'd like to access the application. The firewall manager looks at the web application firewall that has been set up, and the firewall has not blocked the application that a customer is trying to enter from, and then the request gets in. When a hacker comes in, because we have seen either through guardrail or by monitoring it, we have identified that there have been lots of malicious requests from either an IP address or a range of IP addresses. So we block those IP addresses. So in the right, when the malicious request comes in, the web application framework blocks the request, so it doesn't get into our application itself. So it's blocked at the API gateway level or application load balancer level, so it doesn't get into our application at all. Okay, after web application framework, which talks about access control list, I want to talk about something which may be confusing for people who already know about EC2 instances and access control lists. If not, we'll revisit this when we actually touch EC2 instances. EC2 instances, we built something called a security group, and like each EC2 instance has to be assigned to a security group, and the security group is at an instance level. So it's for each instance that needs to be assigned to a security group, and it needs to be assigned to it. It's mandatory. But an access control list is at a subnet level, and a subnet is a part of a virtual private cloud, and virtual private cloud could have multiple subnets, and for each subnet we can actually have an access control list. We can say which IP addresses can actually access this subnet, and those are actually optional, but it's preferred to use it because security is one of the most important things that you can do. You can never say like you could never take it for granted. So this I wanted to point out in the instance that a lot of questions come up where they confuse you with access control lists along with security groups. So when they talk about access control lists, it's at the subnet level, um, and sometimes it's called the network access control list. Sometimes it's called the access control list, but it's at the subnet level. It's a subnet could have multiple EC2 instances inside it, or it could have one EC2 instance inside it. And a subnet is part of a virtual private cloud. So if you don't understand what a virtual private cloud is, we're going to talk about it next week in detail. Um, but when we talk about a subnet is um, a part of a virtual private cloud, and a virtual private cloud for now um, is a barrier where you set up your EC2 instances, and that barrier prevents anybody from outside your corporate network or from outside your group network to be able to talk to this virtual private cloud. Okay, that was a bit heavy for today. I'm going to stop right here, and then thank you so much for joining. Tomorrow we'll continue with the security and compliance portion of this, um, and then we'll take up the other aspects of um, of getting certified as a AWS Cloud Practitioner. The last 2 to 3 sessions would be more about looking at example questions and trying to answer them. But now because security needs a lot of theory, I've just completed one question today. And remember, we'll also go back to our example where we are trying to build a chat application, and we'll refer back with that example so that you understand what each application is, what each AWS service is, how do we use it and how do we not use it, why should we use it and why should we not use it for our application. That will give you all that information. So again, thank you so much for joining today. Tomorrow we'll continue with compliance and security, and then we'll go on to the technology aspects, the multiple AWS services that come in there. Thank you. Bye bye.